Okay, let's do a couple of quick examples of cars accelerating and cars at rest. So Newton's first and second law examples. You may need to watch the videos on free body diagrams to understand what I'm talking about when I say the 5 questions you need to ask and the is there gravity and all that. But let's get started. A car at rest. The car is sitting there. So is there gravity? Yes, there's gravity. Is it sitting on a surface? Yep, sitting on the road. So that means there must be a normal force. Is something pushing or pulling on it? Well, there's no rope attached to the car in this question. There's no hand pushing it, and you're not stepping on the gas, so the car wouldn't be at rest. So there's no applied force. Is there friction? Well, if you pull on the car a little bit, then friction would appear. But at this point, there's no friction. So at rest, so Newton's first law applies. Forces are balanced. So then this must equal that. My diagram is done. Let's take a look at this one. A car is accelerating to the right. Okay, is there gravity? Yes. Is it sitting on a surface? Yes. Is something pushing or pulling on it? Well, when your car accelerates to the right, you step on the gas, the engine applies a force, you have an applied force. Car is moving down the road, there must be friction, so there's a little bit of friction. Now I look at the size of my forces. I say the car is accelerating to the right, so to the right is positive. Does it look like there's more force to the right than left? FA is bigger than F friction, so there's more force to the right than left. Yep, it can accelerate to the right. How about up and down? Well, it's not accelerating up or down, so the ups and downs must add up to 0. Those two must be equal. Now there's an equation that governs this. No matter what question I ask, you should be able to answer it given the equation. The equation is Newton's second law. F net equals ma. And this means add up all the forces in the direction of acceleration, and they'll equal ma. So let's add up all the forces in the direction of acceleration. Fa is positive. Force of friction is backwards, so it's negative. So Fa minus force of friction equals ma. I could solve for the friction if I wanted. I could solve for the mass of the object or the acceleration. This is the equation that's going to give it to me. In the other direction, the equation would be Fn minus Fg equals 0, because there's no acceleration in that direction. So if I wanted to find Fn, I could, because it's equal to Fg, and I don't know how to calculate Fg. Let's try a couple more diagrams.